Now here you can see the components used. This is a PIC18 Explorer board which has a microcontroller PIC18F8722. There is a pigtail smart card daughter board attached to it through which we can access the smart card ECOS3. The PIC microcontroller is connected to another microcontroller which is MSP430F2618. This microcontroller is connected to a CO sensor module which detects the CO emissions from the vehicle exhaust. It sends signal when the emissions are high. The microcontroller is further connected to the prototype of vehicle idling test circuit where an encoder is mounted on a motor. It provides a signal to the microcontroller whether the vehicle is in idling condition or not. Further, there is a connection to the wireless module CC2520 circuit. This is a transceiver which transmits signal to the corresponding CC2520 transceiver. This transceiver transmits a signal through an IC MAX232 to the minuscule database system, which is a laptop in this case. First of all, here we have our smart card module. We have two smart cards numbered RJ9784 and RJ3969. When user inserts the incorrect smart card, the ignition circuit of the vehicle is not completed. The completion of ignition circuit is depicted here by the lighting of LED, which occurs when UID, that is the user identification number of smart card, matches with the UID already stored in the reader microcontroller, which here is the PIC18 Explorer board MCU PIC18F8722. The emission norms values are pre-stored in the smart card for the specified vehicle. These values are transmitted to MSP430F2618 from the PIC18 Explorer board microcontroller. Then, here is the fuel emission sensor module. Exhaust gases from the vehicle are directed to the sensor through the pipe housing. The sense phase of the module is activated only when the vehicle is idling. Since all the current emission norms are specified only for the vehicle idling state, commencement of idling state of the vehicle is communicated through the microcontroller. This is achieved here by a simple DC motor circuit with an encoder. Over emissions are visualized by the closed LED of the sensor module. Sensor reading obtained during sense phase is continuously compared with threshold fed to module by MSP430-2618. As and when the emission crossed the threshold mark, CO concentration at ALR is transmitted back to MSP430. After receiving high from ALR pin of sensor, the MSP controller sends a signal wirelessly to central system. Over emission count is done at MSP430 and the penalty warning is transmitted forward to the server through the communication module. This is server end of communication. Information transmitted from controller consists of vehicle number. The wireless communication is depicted here by using TI's CC2520. In commercial model, this will be done using existing GSM and CDMA networks. The signal carrying the defaulter's user ID received from CC2520 are transmitted to the central database system, which is laptop here, using a MAX232 logic converter. The user ID of the vehicle is fed into the database through incoming file obtained from the software Advanced Serial Port Monitor that provides a software interface for serial communication. The user ID received is matched with the vehicle owner's information database in order to penalize the defaulter.